Watch this to clear up the absolute monster that is organic chemistry for triple students. Save this so you can watch it before your exam. We start with the structure of alkenes. Remember, they're the unsaturated hydrocarbons. Unsaturated meaning they're not filled with hydrogen because they contain a carbon-carbon double bond. That's their functional group. Their general formula is CnH2n. And know those first four alkenes: ethene, propene, butene, pentene. Notice I didn't say methane. That's because it doesn't exist. Methane has a single carbon, so it's impossible to have a carbon-carbon double bond if you've only got a single carbon, so methane isn't a thing. That double bond that the alkenes contain make them extremely reactive. They're involved in addition reactions, addition polymerization, which I've just made a video for. Make sure you know how to draw the displayed structural formula of those first four alkenes, as well as their addition products with hydrogen. Adding hydrogen to an alkene produces an alkane. With water, adding water to alkenes makes alcohols, and halogens. Adding a halogen to an alkene will produce a dihaloalkane. And for each of those, the spec says know the conditions for those reactions to happen. Adding hydrogen needs a nickel catalyst and a temperature of 150 degrees. To add water, which is hydration, you need an acid catalyst, high temperatures and high pressures. With halogens, it happens quite rapidly. The double bond just opens up and you can chuck the halogens there. That's the reason the bromine water test works, bromine being a halogen. It's how we test for alkenes. It turns the bromine water from orange to colorless as it reacts. That's alkenes. Next, alcohols. Alcohols contain an OH functional group. The first four are methanol, ethanol, propanol, butanol. Fermentation is used to produce ethanol. Know the conditions for that reaction. For fermentation to occur, we need an aqueous solution containing our glucose to ferment. We add some yeast and use a temperature of around 30 degrees. Fermentation is an anaerobic reaction, so we also need to make sure there's no oxygen present. And from that, we turn the glucose into ethanol and carbon dioxide. Know these reactions with alcohols. If you burn or combust an alcohol, it produces a nice clean flame, as well as products of CO2 and H2O. When reacting with sodium, it will be fizzing because hydrogen gas is produced. If you add an oxidizing agent to an alcohol, it produces a carboxylic acid. Also, understand all of the alcohols are soluble. They'll all mix with water, but solubility will decrease as the chain length increases. Remember those first four alcohols, methanol, ethanol, propanol, butanol? You need to know what they're used for as well. Methanol is an industrial solvent. It's also used in antifreeze and it's a feedstock for other chemical reactions. Ethanol is used in alcoholic drinks. It's also used in fuels and as hand sanitizer. Propanol is used as a solvent in cosmetics and pharmaceuticals, and butanol is used as a solvent and a fuel. Great, that's alcohols. Now carboxylic acids. Carboxylic acids have a functional group COOH. The first four: methanoic, ethanoic, propanoic, butanoic acid. Carboxylic acids form weak acids because they only partially ionize in solutions. Remember, partial ionization means fewer H+ ions released and therefore a higher pH, less acidic. This means their reaction